Good afternoon, everyone, or early evening, or good morning, wherever you are. Welcome to our info session today as part of the Columbia Climate School's professional learning program. And you'll hear specifically today from Dave Porter, who's going to be overseeing the workshop Polar Warming and Ice Sheet Melt, Fundamentals of the Cryosphere, Global Changes and Impacts on Coastal Communities that we have this spring. He's going to provide an overview of the topics and the dates and what you should expect to get out of this workshop. Before I turn it over to him, I just wanted to give you a bit of information about our professional learning programs, as well as the Columbia Climate School. We are actually the first new school to be established at the university in 25 years. So we are extremely excited about the opportunities here that we have, particularly when it comes to expanding our educational offerings, both on the degree side and the non-degree side. And we're hoping that the new school is going to be able to draw on the university's strengths across climate science and many other science and environmental science subjects, and really build the capacity for a hub for our existing world-class research centers and programs. These programs and centers include the Lamont Doherty Earth Observatory, which is where Dave is based, and he's also going to share a little bit more about his own personal experiences and his scientific work, and hopefully that is helpful for you as you try and decide whether or not this is a workshop that you'd like to participate in. So these are non-credit workshops. There are no transcripts. It's open enrollment. There is no homework. We will suggest readings, and if you would like to participate in office hours or have further conversations with the instructor, we can make those opportunities available. But these are outside of the purview of our degree programs, and they're offered primarily after the workday has wrapped up on the East Coast, so that we're hoping to provide some additional flexibility. And it's been interesting thus far, the individuals who have signed up for these types of workshops, many of whom are interested in learning more about climate and sustainability issues, many who are interested because they are looking to pivot to a climate or sustainability field or career, others who are taking this because they want to engage in lifelong learning and self-learning. And we've had folks, everyone from graduate students and undergraduate students who are still in school and perhaps at other institutions, all the way up to individuals who have retired. And so really there's a very broad range of participants. There is no perfect profile for someone who attends these workshops. And we find that is actually makes the dynamics way more interesting than if it was just, for example, an undergraduate class or a graduate class, because you're bringing in voices and perspectives and experiences from all over. So these workshops are led by instructors who are involved in our degree programs and who lead very active research projects or are involved in research. We maintain an extremely high quality of programming and content when we make sure that we bring our experts to you. And so, as I already mentioned, so these are very flexible. All the sessions are recorded so that if you do miss a session, it is totally okay. We have access to the recordings immediately, pretty much after the workshop. These are all remote for the foreseeable future. That gives us some flexibility in terms of who is able to participate from different locations. Slides will also be made available, as well as suggested readings. So everyone receives a certificate of participation from the Columbia Climate School with the title of this workshop and the number of hours that the workshop was held over, which is 15 hours for these professional learning opportunities. And these are fee-based workshops, and there are reduced rate options available for those who work in government, nonprofit sectors. If you are a Columbia alum, or if you have participated in past workshops, feel free to email me about the reduced rate options, and the fees are listed on our website. So I'm going to turn it over to Dave. I will keep an eye on the Q&A box for today's session. And if you have any questions that pop up during the talk, feel free to jot that in there. And we're also going to open it up to everybody at the end for additional Q&A as well. All right, so Dave, if you want to take over.
Yeah, great. Thanks, Cassie. That was a great intro. And just like to start out by saying, yeah, I do a lot of educational and instruction across all the ranges of levels. And so I'm really excited to participate in the professional learning program and reach more people and kind of, I love what I do, and I'm really excited to share all of what we're learning about polar change and what we can do about it. And so this is it's a great opportunity for me, and I hope that all of you are excited too. So yeah, this is, as Cassie mentioned, I'm a research scientist at Lamont Doherty, which is newly a part of the climate school. So I'm getting used to saying that, but it's one of the premier institutes for environmental research in the world. So I'm excited to bring all of the cool stuff that we're doing from Lamont to you guys. So I'm just going to get into sort of the quick outline here. Is just I'm going to go through a little bit of the background of the course, and what we should expect, but then we're going to do the overview, objectives, so kind of what we're going to hit, a schedule so that you can see if your favorite topics are covered, and if not, I'm open to suggestions. So give you sort of a weekly outline, and then kind of give you some background on myself, and other people will have guest lecturing. And of course, there's going to be a Q&A at the end, so save all of them up or type them in the chat as we're going along. So part of the background is we hear a lot of news about changes globally in the environment, and we tend to hear ones from the poles, and some of it is because the imagery is really nice, like this picture of a iceberg that I took from an airplane. So it's really engaging imagery. But sadly, the other part is that this is where, as people say, the canary in the coal mine. So this is where the effects of climate change are most noticeable. So, there's lots of changes associated with our environment by fossil fuels and other pollutants, and just generally man's activities. But there's a lot of climate variability. And so what we're always looking for is the signal and the noise. And in the Arctic, the signal is so strong that it's very clear. And so these are some highlights that have shown up just in 2021. So this is from the Arctic Report Card, which is something that the National Oceanographic and Atmospheric Administration puts out every few years. And so this is kind of like the headlines you might have seen in New York Times or Washington Post. So we have tundra greening. So there's data that shows that it's greening faster than ever. So which is, that's a positive thing, right? If you're a community who's interested in farming in the tundra. So this is kind of a theme we'll see here, is that there's lots of changes, and some are good, some are bad. And we'll kind of look at the aggregate of all those in a bit. Arctic rivers, that they're more and more discharged. There's these 4 large rivers that dump into the Arctic Ocean, one in Alaska and the 2 in Eurasia, and lots of more water flowing out, and that changes fresh water and nutrients delivery, and it's just this intensification. Sea ice is dropping. Everyone knows about that. Arctic sea ice, people have used the term death spiral. There's tundra browning. We also see that over here in the upper right. So that's also where it's drying out, right? So now I just said it's getting greener, and now so we're learning there's lots of nuances here, and I think this is part of the big messaging issue with climate change, is that the climate is complicated, and but I think that makes it really interesting. So marine garbage, there's been news about that. There's we talk about microplastics a lot, but there's macroplastics, bottles, things washing up on the Arctic shores. And that's only going to get worse as shipping lanes start to move through the Arctic. We have food access issues, which are compounded by COVID-19. And so there's lots of, these are the headlines, these sort of in 2021 noteworthy things. But yeah, I thought this other one was interesting. Beaver range expansion. That was the first I've heard of it, but it's a really big issue. And it's there used to be all these little rivulets, but as it's getting warmer, the beaver population is expanding northward. They're making more. They're finding more vegetation to eat, which is great if you're a beaver, but it's really affecting the landscape. And I think that's really interesting and something I didn't think about. And it's it's shows how intricate the problem is. So those are highlights from this year, the headlines, but really we've been collecting data for a long time, and that's not, scientists don't report headlines. That's not what the science is. It's collecting crucial data very carefully over a long period of time, so we can look at trends. So we can take out seasonal signal, reduce noise, and start to pull apart the anthropogenic change. So this is from the special report on oceans and cryosphere, which I had a paper in. And so this is looking at, it's a subcategory from the IPCC, but this is specifically the cryosphere and ocean special report. And this is looking at time series, so the change from, in the most case, the mid-1900s, and some through current, and then there's model projections to the future. And so what we see here in the brown is the historical. And so in all of these plots, we can see big changes happening. And so, we're getting increased temperature. So that's this upper left one. We're getting decreased pH, ocean pH. So, right, that's acidification. We've heard about that with coral bleaching. There's more heat waves. We've heard about that, especially in Eurasia. Ocean heat uptake. You may have heard of this from the missing heat or missing temperature from about a decade ago. And it turns out it's being absorbed in the ocean. So we've been able to find the missing heat. Loss of permafrost, big declines in snow and sea ice, which is both in the Arctic, but also in mountainous regions. So if you're interested in skiing and snowboarding, this might be of interest to you. And the ice sheets are melting, which changes sea level, and on the East Coast, it's rising pretty significantly, and it will only accelerate. So if you like the beach, or if you have property nearby, it's of interest to you. So this is kind of, it's been said before from a polar researcher that what happens in the Arctic doesn't stay in the Arctic. And that's true, because there's all these changes that are happening there. They're felt first because of a couple things, and we'll talk about that in the workshop. But what happens there then affects mid-latitudes where we live. So I shouldn't say we, I don't know where everyone's from, but I hope there's some polar people here. So I say this is depressing, but we'll get to solutions in a bit. So, and that's kind of where I hope that this workshop can go, is that, you have to look into the data, and it is depressing if you just extrapolate, look at these red curves in this plot, and that's depressing. But, we have the ability to change that red curve, right, into the blue curve or another curve. And so I think there's, we need to stay optimistic, and there are reasons to. And so we'll get into that at the end of the workshop as well. So those are the changes that are happening, and these are the impacts. So this is impacts both on the physical system, but also on the human infrastructure. And so, we're not going to go through this now, but what's interesting to me is these are just a sampling of things, yet look at how varied they are. So the way to read this graph is, so we've got different regions on the top, and then there's like increased and decreased and positive and negative. And then the dots are confidence. And what's there's like some things that are obvious, like, okay, temperature is going up in the Arctic, coral is decreasing, but then there are other places, blue, that's positive. So, in the Southern Ocean, so that's the ocean around Antarctica, the polar benthos, that's benefiting from this increase in global mean temperature. So this is really, it points to that there's global changes, but there's local impacts. And so it's good to know what's going on globally and understand it. And then it's that next step to say, how is it going to affect my community or this community I'm working with? And that's where all of this work that's done by mostly federally funded researchers to put in reports like this really come in handy, so we can look at local impacts. And that helps us decide how to become a more resilient community and protect the things we value. So the workshop overview. So yeah, a lot of this is what I already said, but that the poles are changing. And so this is threatening coastal infrastructure in the Arctic. It's threatening coastal infrastructure here. It's opening up new shipping lanes. It's opening up opportunities for exploration, mineral extraction, which, as we hope to move away from a carbon-based economy, perhaps those aren't as big of a issue. The economies of drilling for oil in the Arctic may become reduced. However, for instance, there's a big interest in mining sand from fjords in Greenland, and I work with some Greenlanders who are part of these projects. So it's there are impacts that are really not obvious. So if you have less sea ice in a fjord, it's going to be easier to dredge that sand up. But then how is all this dredging in a fjord going to affect the benthic ecosystem that the halibut feed on? And the halibut is what the Greenlandic fishermen catch. And fishing is like half of the economy of Greenland. So you can see how this is very interconnected, and that's what I think is so interesting about this. And it can, there's way more material than we can hope to cover in a single workshop. But this is, I hope that kind of focusing on the poles and polar impacts will set you off on the right path. So then, as I kind of already mentioned, there's changes in snow and permafrost shifting food and water resources. So that's different hunting grounds, different fishing grounds. Our cod moving further north. The lobster fishery on the East Coast is moving north, right? So that's great if you're a Maine lobster harvester, but terrible if you're off the Massachusetts or in Long Island. There's already no lobster harvesting anymore, just in a few decades. So coastal erosion, it's important here, but it's very important in the Arctic, where your coast used to be held together by frozen blocks of ice, frozen soil. And as that melts, it becomes more easily erodible, combined with loss of sea ice means there's more wave action. So, there's pretty much every bit of infrastructure has an impact by environmental change. And we're going to touch on some of the most dramatic of those, but also some of the ones that for communities that I work with in the Arctic. And then the final thing is we're just going to look at you'll come away with sort of a better picture of the cryosphere, which is the term we use for the frozen part of the planet. So that could be icebergs, it could be just the polar oceans. It also could be glaciers in high mountain Asia or Alaska. It doesn't have to be high latitude. So kind of the frozen Earth, analogous to the atmosphere, biosphere. So this is the cryosphere. So you'll walk away with an understanding of how the cryosphere fits in the largest climate system. So I'll just show you some of these are all videos I took while in the field, and I'm hoping to keep the workshop interactive. So we're going to have breakout groups. We're going to look at data sets and videos, and just kind of I'll just won't describe these here, but I'll just say that we collect data lots of different ways, and we're going to dig into how scientists do work in the poles as sort of a because I think that's some question I always get, and love sharing it. So and then learning outcomes, or explain some of these. So I'll just kind of hit the ones I haven't so far, which is we're projections. So projections 2100, 2300. And the big question is Antarctica. So what's going to happen to Antarctica in the future? Because that's the big one for sea level rise on the East Coast. So we're going to, that way someone asks you, are you scared? When is Battery Park City going to be underwater? We'll start to, we'll have some good evidence-based answers for you. So like I said, we're going to talk about techniques that we at Lamont use to study the ice, linking changes from high latitudes to our local level. Then we're going to talk about responses, adaptation, and resilience. So yeah, this is the tentative schedule. And like I said, we have, there's pending changes depending on feedback from registered learners. But so far, this is what we're doing. And so it's going to be start on April 5th with a introduction section. And so we're looking at Tuesdays, generally after work. So on the East Coast here, 6 to 8:15, which gives us a solid 2 hours for the course. And that includes, we're going to have some breaks in there, and it's going to start out with some lectures, some slides, and then we're going to sort of have much more of a discussion. So there will be plenty of content, but I want to be ready for any questions that come up, and make it very dynamic as we can. So that first one's going to be sort of like a introduction by me, and then sort of an ask me anything, where you can just, we can sort of get a quick overview of participants' backgrounds as well as mine. We're going to look at projections of climate change and specifically cryosphere change. Then we're going to get into the 2 sessions of fundamentals. So we're going to learn about land ice, which are glaciers and ice sheets. So we're going to learn how they flow, how they're changing, why they're unstable, and why we worry about them. Snow cover, we're going to talk about albedo effects and sort of relationships with vegetation. And then the second fundamental course is on marine environments. So we're going to look at sea ice, which is one of the more newsworthy parts of the cryosphere, and how it's all the biology that depends on sea ice. And that's what my PhD was in atmospheric effects of sea ice loss. So I'm excited about that one. And changes in the polar oceans. So like another biology circulation theme. And then 1 week of how we measure the change in the cryosphere. And so that is mostly going to be from scientists at Lamont Doherty. And we're going to talk about studying it in situ. So that means being there, collecting data somehow, stakes, buckets, et cetera. And also using remote sensing, so satellites. So yeah, we're going to go through that. And then that's kind of the ending of the physical science part, at least the underpinnings. And then starting May 10th, we're going to have 2 sessions on impacts. So as I was saying before, change in the cryosphere doesn't stay there. So that's sort of the second one, which is what are impacts of melting ice sheets and changing snow cover? How does that impact the globe? So everyone's thinking sea level rise, and hint, that's going to be a big one. And we'll break out into teams and sort of do case studies of different locations around the globe. And then the other one is I'm involved in a project in looking at how changes in Greenland affect Greenlanders. And so we don't think of it this way, but there's people that live around the ice sheet. So how are these effects of affecting the people that live there? And the same goes for Alaska and other northern communities. And finally, we're going to finish up with sort of the positive part, which is solutions. What are scientists and engineers talking about for solutions. So some of these are going to be geoengineering, some of them are going to be political, and this is going to be also discussion, a little more discussion based, where you can bring your own ideas, and going to be some background reading. So yeah, so I won't talk too much of my bio since I already did that, but basically I'm a very interdisciplinary polar researcher. So I started out as a meteorologist, got my degree from Rutgers, but then I've been studying the ocean and ice sheets in different ways ever since. So on airplanes with NASA, on icebreakers to East Antarctica, and like I said, currently working with local Greenlanders on changes there. And we have a couple of guest lectures to help spice things up, and they're also experts in their field. So we have Johnny Kingslake, who's a glaciologist here at Columbia, and also Margie Turin, who's educational master, and she's kind of leading up the educational part of the Greenland project. So she can help us on coastal impacts. So yeah, that's all I have. And I guess, yeah, we'll take some questions and offer any more insight, and hopefully you can join us.
Great, thank you, Dave. So we have two questions from William in the Q&A box. The first is, these are both content questions, so I'm going to turn that over to you. And the first is the instability of the Thwaites Glacier increasing according to expectations or faster than the modeling has suggested?
So yeah, it's great. Thanks for bringing up Thwaites Glacier. So I'm also, this iceberg is in front of Thwaites. So I was on a British Antarctic survey doing aerogeophysics. So this is a Thwaites iceberg. But yes, Thwaites is a big concern. It is people called it the Doomsday Glacier, which is a little pessimistic, but it is the key to West Antarctic, the West Antarctica melting. And what's interesting is that which ice sheet melts affects different places. So for instance, when Greenland melts, our sea level actually doesn't go up. Ours being, sorry, New York centric here, but, and we'll get into this. So this is something we'll talk about is, where you are, you can see what sea level matters for you. So, or which ice sheet matters for your sea level. But so for the East Coast of the United States, Thwaites matters a lot. So that's one of the reasons why we're mounting this big program there. But as far as whether or not it's meeting or beating expectations, that's to be seen, which is, I know, maybe getting out of a tough question, but partially it's that, and we're getting into the science already, but West Antarctica sits on a very, the crust that it sits on likes to rebound more than other places on the Earth. So the ice sheet is weighing down the Earth's crust. So when we start to remove ice, it actually uplifts. And that's something that can slow down Thwaites. And so right now we're studying, there's a ship going down as we speak to look at how the ocean's melting the front. And that part is moving just as fast as we worry about. So the ocean is melting it very quickly, and we may lose the remaining tongue in a few decades, if not sooner. However, the one uncertainty is whether or not this rebound of the Earth actually can protect it. So there's new projects going down now to measure how much this Earth can lift up. So I guess, yeah, the jury's still out, but you should see some more as these Thwaites projects wrap up in a few years.
Right, and the second question, also from William, and the more content focus, is how much of a threat does melting permafrost pose for increasing greenhouse gases in the atmosphere?
So that's could be a lot. So this is one of the potential ticking time bombs for global change. So there's two. One is releasing carbon. So there's been a lot of frozen carbon locked up in this permafrost, and there is a bunch of nutrients that critters would love to eat and grow. So there's sort of that's the carbon dioxide pathway. There's also the direct pathway of gases like methane. So in lots of places, there are methane seeps that have been locked up in clathrates and other sort of features. And this also happens below the sea floor too. So you can have this on the shelf underneath the ocean. There's water, so there's melting there and will release the methane. And methane is it has a shorter lifetime, but it's a much stronger greenhouse gas in its radiative effect. So yes, there's big concern about a methane burp almost. Yeah, so that's definitely a active source of research.
Great, thank you. So the next question is, would you suggest this course for someone with a background in geology? I'm happy to take a quick stab at that, and then maybe Dave can weigh in as well. I think that it's certainly beneficial to come to this with a geological background, but obviously not required. I think in terms of if you have that background, I think so many of our scientists at Lamont Doherty started with a background in geology. I think likely because of the different practical approaches, but thinking about what Dave has specifically said about natural resource exploration and the possibilities that open up, that is sort of an immediate thought in terms of if you do have a geology background, that could be very useful. But again, these workshops are designed to include everyone with different backgrounds, and it certainly is not a requirement. Dave, do you want to add anything to that?
Yeah, I think that we won't be doing too much geology such that it'll be redundant with what you've already had. So it's going to be it's definitely a lot of not geology. So there's a lot, oceanography, atmospheric science, glaciology, biology. So yeah, this is going to be kind of a good interdisciplinary workshop.
Great. Thank you. And the last question here that we have is a nice way to also wrap up the info session is, where could one use this information to create greater impact? So I think there's a couple of different ways, just as examples, and then there are, I'm sure I will miss information as well. But I think one of the things is what Dave touched on at the beginning, which was that, here's what you see in the news. Here are the headlines that are reported. But this is a workshop that's really an opportunity to get behind the science and learn about the fundamentals so that you can either make decisions with that depending on your field. So decision makers in conservation, environmental management, potentially also in the in the private sector as well, to understand the risk to coastal communities and our food systems, agriculture. I think there's many implications and areas for impact. Additionally, I think communication is also a big piece of this, because I think, again, what we see in the headlines is only a small piece, because we can only report 1,000 words at a time, or I don't know what Twitter's character limits are up to these days, but having tidbits of information without having an understanding of the overall systems that are in place, I think this workshop really aims to address that. And I think communication to those communities locally, whether it's coastal communities or non-coastal communities, or in different locations. I think there's a lot of potential for impact to bring this sort of knowledge and understanding, but also to use it in a practical way. Dave, do you want to add anything?
No, I think that's that's exactly what I'd hope. To answer that. So I think it's it's understanding that if you wanted to get more involved in workshops or outreach events or advocacy, that this is, there's so much. When I do outreach events, I get so many questions, and so I'm excited to sort of help create an army of information disseminators. So I think that's a good answer.
Great. All right, well, I don't see any additional questions. So what we'll do is we'll share the recording with everyone in case you wanted to hear again about some of the topics. And in the meantime, if you do have any questions about the workshop, feel free to let me know. We sort of put these topics together, hoping that this is something that participants would like to see. But as Dave said, if there's particular topics that you didn't necessarily see covered, we are very open to suggestions. These are great opportunities for you to also contribute to your own learning. So definitely open to suggestions. And again, if you have questions, feel free to reach out. If you have questions about the rates and the reduced options, please also reach out. You all have my email. And Dave, is there anything you want to add? Just last words?
No, just if this last snowstorm got you excited and you went out and played, which is I love the snow, so that's not bad weather, it's good weather for me. Hopefully I'll see you in the workshop.
All right, fantastic. Well, thank you very much, everybody, for taking the time to join. Thank you, Dave, and we'll be in touch soon. All right, have a great rest of the day, everyone. Thank you.
Thanks.
Bye-bye.
Have a good one.